Good evening, everyone. My name is Michael Goss. I'm chairman of the Civil Division here in Engineers Ireland. Just before we start, can you just put your phones on silent? And the exit doors, in the event of any emergency, at the door that you came in, and the door down here in the bottom corner. Tonight's presentation is being co-hosted with the Institute of Civil Engineers ROI branch and the Water and Environment Society here in Engineers Ireland. The title of this evening's presentation is Cape Clear Island Hydraulic Storm Gates. We have two speakers, Mr. John Norris, Chartered Engineer, Director of Malone O'Regan Consulting Engineers. John has over 30 years design and construction experience, and Richard Browne, Chartered Engineer, Director with L&M Keating, who was recently awarded Engineers Ireland Chartered Engineer of the Year 2015. And he has acted as project director on this project with overall responsibility for the construction of the works through his construction team, and was design lead and coordinator for contractor design, build and temporary works on this technically challenging project. The presentation, I think, is about 40 minutes, and then we just open up to the floor then for questions afterwards. So without any delay, we'll start the presentation. Thank you.
Hello everybody. Just by way of introduction, in case some of you don't know where Cape Clear is, it is off the southwest coast of Cork. You can see Baltimore there on the diagram on the map, and Cape Clear is on the outside. Point it here if I can, even though my angle is not good. There. It's about 8 miles off Baltimore. It's about 45 to 50 minutes on the ferry. And there are ferries from Baltimore and Schull. The island itself is about 3 miles long, 1 mile wide. Back in pre-famine times, it had a population of over 1,000 people. Today it's about 125. But it does get a good few visitors. There's an Irish school there, and there's a bird observatory there, first in the country, there since 1959. So the island population, of course, are very dependent on access to the mainland for employment, for secondary school education, third level education, for all their services, doctors, and for various other foods and what have you. So the harbour then, the harbour is located, let's go back here. The harbour is located on the northern side of the island. There's actually another harbour on the southern side, but that's very exposed to the Atlantic storms and waves. So I'm trying to point to it, but my angle is not very good. There, North Harbour's there. So the problems with the North Harbour is the lack of shelter. There's very turbulent conditions during storms. And the Bull's Nose, which I'll show you in a minute, if you look at that map there, you can see the Bull's Nose. Can you see it? You can see it there, can you? That serves to protect the harbour from the incoming storms. The width between the Bull's Nose and the rock face is about 11.5-12 metres. And the harbour itself then comprises of 3 separate areas. The outer harbour, here, with a beach at the back here, a road running along there. The outer basin, which is that one, and the inner basin, which is this one. And prior to the installation of the gate, during storm events, vessels used to retreat in here. There's a middle thing here called a boom wall, and that can be closed off with stop logs during stormy conditions. So the stop logs were inserted in here between a recess in the boom wall and a recess in Duffy's Pier, which is the middle pier. That pier is about 130 metres long. And then you have the outer breakwater pier, as it's called, with the Bull's Nose at the end of it. And that Bull's Nose helps to restrict the incoming waves here and gives you much more shelter conditions in here, but nevertheless very exposed, particularly to storms from that direction, which is about 270 degrees direction from the northeast. Come back then. So lack of shelter, very turbulent conditions during storms, and the bull's nose critical to protection. There's a lack of depth, there's very limited berthing capacity, and the road access is also exposed to wave overtopping. And the existing structures are very vulnerable. Boom wall in the middle, which I'm just going to pronounce, is very narrow and is not in particularly good condition, it's very old. And stop logs we've spoken about. So the reasons for the development then. Socio-economic is the first. The island is very dependent on harbour facilities, so it's important that they have access to the harbour at all times. And the harbour had fallen into disrepair, particularly the Bull's Nose, which I showed you a while ago. If you look at the photographs there, there's some very serious cracks, and these were getting worse and worse. There was ongoing subsidence. If you compare the photograph of those cracks 10 years ago with what they were prior to development, you'd see a significant worsening, deterioration. And the consequences of the collapse, of course, were very serious. If that Bull's Nose were to collapse, then the harbour was exposed to very high waves, which would inevitably cause very serious damage. And waves then would also breach into the outer basin and put the boom wall at risk, and the shelter, of course, would be where boats are sheltered would also be at great risk. So it's important that something be done, and something be done quick. So there was a lot of information gathered over the years. There was site investigations with boreholes, sampling and testing undertaken. There were hydrodynamic studies carried out in 2001 and 2002 by Procurement, and they established that the most penetrating waves were when the wave direction was 280 degrees. Solutions were proposed, but the fact that long waves weren't considered in their study was deemed to be an issue, so it was decided that more studies were needed. So HMRC in Cork were brought on board then to carry out some physical modelling, which they did, and they modelled 12 different harbour layouts and concluded eventually that a storm gate was necessary, that no matter which harbour layout they came out with, that the storm, the waves were going to cause damage. And they also developed a long-term plan. So this long-term plan, the middle pier is Duffy's Pier as it is today. The breakwater pier that you saw earlier on would be gone. The slipway as it was built as part of the development, and then the harbour was going to be increased. The boom wall would be demolished, and you end up with a basin that's, I think, about 100 metres by 100 metres, which could cater for some visiting yachts, for the ferries, and some fishery vessels. And also kept the beach in the outer harbour. The beach there is the only beach on the island. Most of the island is surrounded by cliffs and rocky outcrops, and this is about as good as it gets, and it's a very relatively poor beach with limited sand and that, but it's the best they have. So first step then was to look at what information was required to allow the development to be designed and progressed. So even though there was several boreholes in the area, they weren't sufficiently targeted, so we identified some more and got them done. The wave data was, again, there was some information but not enough, and the analysis of the waves was good, it was still lacking, so we needed to understand it a bit better. So the results of those studies were that the site investigations in the vicinity of the Bull's Nose indicated that rock levels varied considerably, and that, of course, was probably the reason why the Bull's Nose was collapsing, and that was sitting up partly on rock and partly on poor ground, and over time then was starting to settle and deteriorate. The HMRC data provided much more information than previously available in terms of existing wave information, and the Delta Res, who are Dutch-based outfit. They analysed the waves and looked at the wave penetration into the harbour and how it might be mitigated. So their report concluded that the wave penetration into the bay and harbour were a combination of sea, swell and longer waves. And the combination of swell waves and long waves appears to be the reason for the draw. People on the island refer to this draw in the harbour, where boats are being tossed around at different times during storms, and the longer waves and swell waves were deemed to be primarily responsible for that rather than the shorter waves. And of course the output from the Delta Res study, that also gave us some advice and help in relation to what the structure should be designed for. So this is the sort of output plots we got then from Delta Res, and if you look at those, the different colours indicate the different wave heights in or around the harbour and further out. And the deeper the colour, the reds and that are very large, very high waves, 9, 10 and even more than 10 for the darker reds, coming down then to 0, 0 to 1 for the lighter blues or the darker blues on the top one, and the colour's a bit different on the bottom one, but it's the same impact. So the proposed development then, the entire development as proposed on the master plan couldn't be done on cost grounds. There simply wasn't enough money. This was 2010 when this was being spoken about, so we were just starting to come out of the deep recession. So the extent of the development then became the new slipway, the demolition of the Bull's Nose, new Stormgate support structure comprising of a replacement structure for the Bull's Nose, and strengthening works to the Duffy's Pier, the middle pier. The provision of a new 12-metre wide hydraulically operated by-parting Stormgate, and the reclamation of part of the inner basin. And the purpose of that was to provide better road infrastructure. The roads are very narrow in the area, and by widening or borrowing it or taking a piece of the inner basin, we're able to improve the roads locally and also provide better access to the slip. So you see there on the map, the drawing, you can see the slipway, and the slipway had to be built first because the existing slipway is in the outer harbour. It's very small narrow slipway, totally unsuitable for carrying out any construction works. There's another slipway on the island, but it's much further west, and the roads between it and the North Harbour are very, very poor and very, very steep and unsuited to construction vehicles. So the first thing needed was to construct a slipway. And you can see the part of the inner basin that was reclaimed. It's not one shine. It's up on top anyway. There's a close-up on the works. So you have the outer breakwater pier with the by-parting gate between the new Bull's Nose and the modifications to Duffy's Pier or the middle pier. You can just about see the existing Bull's Nose in the background. So we felt it was very important to make sure that the alignment of the new structure coincided with the alignment of the existing structure. That way, so that there would be no worsening, if you like, of the waves penetrating the outer harbour. The by-parting gates then, there's a further facility there, you'll see it in front and behind the gates, whereby stop logs could be introduced, which would allow that dock area to be dried out, and you could work on the gate and maintain the gates, paint them or whatever, or repair them if the need ever arose. The design then was took on board the hydrodynamic studies carried out by HMRC and Delta Res. The US Army Corps of Engineers Shore Protection Manual was consulted on this and used, and BS 349 Maritime Structures was another key design reference. The design considerations, the critical wave, the 1 in 100 year event was what it was designed for. We took into account the variable forces on the gate support hinges and ram during gate opening and closing, and also the potential for buoyancy during construction, because these were hollow structures. And the gate was procured then by means of performance specification and exemplar drawings, which were provided by KGAL consulting engineers who we engaged as a specialist. 7 load cases were considered. Regulatory requirements, this required a planning permission, and that was supported of course by Natura impact statement, by waste management plan, archaeological report and flood risk assessment. There's an old graveyard at the back of the harbour and also an old church. A foreshore lease, the development required a foreshore lease for a number of reasons. The slipway for one, the part infilling of the inner basin was the second part, and also there was some further encroachment on the bed. And certificate of registration, clearly when you carry out excavation works, there's very few options on the island, so the department managed to secure a field from a local landowner, but to deposit material there required a cert of registration and a planning permission. The procurement then, we decided to go on a 2-stage process, civil works initially and the gate. So the civil works was 2-stage process with suitability assessment of candidates for the civil works, followed by a short listing and then tender process. And for the gate, a 1-stage process under a design and build contract with performance specification with exemplar drawings, and then the selected contractor to be novated to the main contractor. So the issues that were encountered then that are going to take heed of in relation to the gate, there was a need, an established need, and the vessels had to be protected during storm events. The location, as I said earlier, the HMRC modelling identified or looked at several different options, but the selected location gave by far the most shelter. Most of the other options were crossing the main flow into the harbour, and the wave heights were much greater, sometimes double. The type, we went for a biparting gate on the basis that at least was a manageable size. Had we gone for a single gate, the loads would be much, much greater and very difficult to fabricate it offsite and transport it to the island. And the operation had to be simple. There's no great expertise on the island, so that had to be kept in mind in the design. The roads are on the island throughout are very narrow and most are very steep. This presented an opportunity at least to widen some of them. The slipway, as I said earlier, the slipway had to be widened. The existing slipway was too far from the North Harbour, so a new wider slipway had to be constructed first. And of course all of this is carried out in an SSC. The Roaring Water Bay and the islands are designated an SSC. This was an interesting, as the design developed, we started to wonder, should we provide a gap under the gate, on the basis that if there was a gap, there would be less likelihood of a stone or a rock or what have you fouling the gate. So we asked some of the specialists to investigate the possibility of leaving a gap, and if a gap was to be left, how big could it be? But the assessment concluded that even a gap as little as 150 millimetres under the gate would result in waves up to 500 millimetres inside. So at that stage we said, look, any gap needs to be very small and preferably eliminated altogether as far as possible. During the procurement stage then, issues arose. In trying to shortlist, inevitably you're going to have a number of candidates, and if you try to shortlist to a reasonable number, 6 or 5 or 6 or 7, whatever it is, inevitably some people are going to be disappointed. And some were, and of course some of them challenged the decisions and wanted to be debriefed, and of course all this takes time. And eventually you get through that, and then you go through a tender process, and when the tenders come back again you have further evaluation. Of course there's further unhappiness when you start talking about non-compliance issues, because even though we got some fantastic proposals, excellent, as good as I've seen, and very, very varied in terms of how they were going to construct the works. You know, different combinations of in situ or in situ and precast, or predominantly precast as the case may be. But a lot of them fell foul of the fact that they couldn't actually deliver, and they couldn't deliver because they were trying to precast part of the structure within the harbour, and they didn't have a foreshore. And because they didn't have a foreshore, we couldn't accept those tenders. So at the end of it all then, it was very complex. It was much more complex than envisaged. It took longer than we thought due to the need to carry out further surveys and studies, due to regulatory requirements, and due to access and weather issues during the construction works, which Richard will speak about now in a minute. The cost increased as a result of all that. But the basins are protected. There is a safe haven for vessels. There is a facility to carry out future works in the harbour in dry conditions. And there is a facility to provide dry dock for maintenance of the gates in situ. So there are huge benefits, and particularly when you consider, you know, the island population, the fact they're so isolated. Thank you for that.
Thanks, thanks, John. So look, I'm going to take you through some of the construction elements of the harbour, and in particular the lock chamber installation and the gate installation. So I'll give you a quick background about L&M Keating. We'll go into Cape Clear, talk about structural arrangement, the key elements, and then some Q&A. L&M Keating, we're a Clare-based company, founded by Louis Keating, owner and MD of the company. We've about 110 direct with us, and some very valued subcontractors that travel the country for us. We've obviously the head office in Clare. I have an office here in Dublin, and we have a new office here in Cork. We've a turnover in around something around 60 odd million. And we do business with all the major marine clients, some very valued customers there. Ourselves, it's a big year for us. In the last year, we've turned 30. We became an Engineers Ireland accredited employer. We opened our design office here in Dublin. So there's a lot happening. We're fairly multidisciplinary, so to survive the last few years, we've been able to turn our hand at or keep all the aspects of the business going. So we've a very good building department. That there is King John's Castle in Limerick, a nice museum job with conservation. We also have the civil department and civil marine department. That's Foynes Harbour, where we built some 1.8 metre diameter combi wall pier. We have specialist plant hire division. Typically we've some hard to get plant, so that's an amphibious long reach excavator, dredging in Limerick, and then we own and operate a couple of marinas. We have a strong background in these D&B maritime civils. So that project there was Knightstown Harbour, a very unique project, 660 metres of floating breakwater. We designed and installed a fairly novel helical anchor mooring system to keep the breakwaters in place, and a good successful job, a real niche job. Here we have Doolan Pier, where we developed a precast pier construction method to deal with heavy Atlantic swells during construction. So traditional methods of formwork were out of the question because every couple of weeks we get a storm and it'll blow anything away. So we developed a method where we could lift in 50-ton precast pier elements one after the other. And anytime we thought a storm was going to come, we just tie them back into each other, infill them, and rock anchor them down to the bed. Some of the more novel jobs can be smaller jobs too. So here we had to retain 1.6 meters of water to carry out conservation work on a weir. Very small job, but unique. This one here is close to home, so that's dredging the Grand Canal. That's where we built our amphibious excavator for. So this is quite novel because we had no pumping on the job, so we dry down a 400-meter stretch of canal and keep the canals going by siphon alone. At the moment we're working on the Dublin Port ABR project, so we've a single party framework there for the next 2 years to deliver quay walls with our JV partners Rowbridge. This is Crossburg Quay. We're doing 165 metres of common quay wall. We're just turning the corner on it now to do another 120 metres. We're delivering a private ferry terminal in Carlingford, so two car ferry terminals either side of the border. But today's project is Cape Clear. So I'll quickly run through project scope. I'll go through the general structural arrangement, how we put it together. I'll talk a bit about design management, which is key to the job here, and logistics. So that'll lead nicely on to the precasting of the lock chamber and the gate installation. So this is the job here. We were lucky enough to be awarded the 2 contracts. The civils, which was the construction of the 70 by 10 metre long slipway, the remodelling and reconstruction of 2 new pier heads, a new X-block revetment, and probably the most interesting aspect of it, the lock chambers, and then the separate contract for the storm gates. John's already described Cape Clear. It's a challenging place to work. Everything has to come by boat. Everything is terribly weather dependent. It's 50 minutes on a pedestrian ferry. It's 2.5 hours for a cargo boat. The harbour itself, subject to frequent wave attack. It gets a heavy swell, as John described, a draw, which is very difficult when you're trying to do any construction work. So we got a traditional contract where we redesigned elements of it, keeping within the broad parameters of delivering a storm gate or a lock chamber with a 12-metre clear opening. This installation had to be a very easy to use installation, so the islanders were going to take control and ownership over the operation and maintenance of these gates. So a large diverse panel of people were going to have to come down and use and maintain these gates in the most extreme of conditions. So we had one of the most challenging design conditions of it was we had to design the gate to take a 4-metre wave height while the gate was opening and closing. So it's a mitered gate, very strong in its closed position, but quite weak in its operating condition. And this all had to be delivered to a CE mark. So wrapped up in a CE mark execution class 2. As John's already described, it was in a special area conservation. It's an island, and all through the works we had to maintain access to the harbour. So that had a large effect on the options for construction. But just to explain or to guide you through the putting together of this, you can split it really into 4 main elements. You've got a gate, you've got the hydraulics that operate the gate, civil, which is the piers, and then you've got the lock chamber itself. So up here we have the bull's nose, which is the pier on the right, and down here we have the existing sheet pilot Duffy's Pier. Our first task was to take down Duffy's Pier, which had already started the process itself. Once that pier was down, the first job we set about doing was installing the lock chamber. Now I'll come to the lock chamber later, but suffice to say it was a precast lock chamber that we elected to do, and that needed very level footing, and that level footing had to be installed up to 7 meters below low water. So we developed a design and technique where we could lower a frame into the water and level it above water to come up with 3 strip foundations that the chamber would bear on. And those strip foundations were surveyed in after the fact, 7 meters below tide to within 3 millimeters of their final position. Then Duffy's Pier, we elected to do Duffy's Pier in sheet piles to keep the structure light and to tend towards prefabricated components. On the bull's nose we used a caisson technique. So we essentially built the pier like blockwork. Leveling, we have a system where we can place these caissons from above water and level them above water, and we can then tremie in concrete to stitch them all together. And that was particularly useful here because we can construct them on the mainland and we can form our curved pier structure, and that's them around here. Once the caissons were in place, we could then install precast L-shaped retaining wall units, and these were laid out along the line of the pier, and then a single face shutter put on the back of them to bind them all together. We then put on an in situ deck, constructed 2 plant rooms for our HPUs, and landed in our storm gates, which obviously open and close within the chamber. So we just talk a bit about design management here. We elected to redesign quite a lot of the structure to suit our construction methods, and we retained quite a bit of design control on this. So we appointed 14 specialist designers, each having a niche, each having a speciality, and we brought them in together under our system and under one CE mark, which suited us down to the ground, because this is all based on, the success of this project is all based on constructability. So our structural designer didn't particularly need to know too much about the wave action in the harbour, or our electrical designer was able to focus purely on the delivery of the electrical elements without having to worry about the temporary works or any installation challenges. And all of that design was heavily interlinked. So if we look at, for example, the position of the ram on the gate, we set that out 4.15 meters out from the hinge point in both directions. But very early on in the contract, we had to do the calculations on this and order our 2 400-ton rams. They were on a 20-week lead-in. They have a 4.563 meter stroke. There's about 10 mil leeway in that dimension, and that had to be set very early on in the contract. But changing that, leaving aside the procurement of those items, changing the position of the pivot point. Obviously it had a big bearing on the gate. The gate had to be designed to cantilever past the ram. It had a big bearing on the concrete structure. These forces, this force vector came back into the lock chamber walls. Those forces had to be translated or transferred out to the existing and new structures. In the meantime, we had things like big buoyancy uplifts that had to be counteracted by rock anchoring. In terms of logistics on the harbour, we landed there with nothing. So there was no slipway that could be used. All we had was a beach. So the first thing we did was we landed a couple of excavators on the beach. We dug our way up onto the island and formed a slipway. Once we had a slipway in place, we could land gear with a landing craft that you see here. Due to the logistics, we tried to precast as much as we could. We set up a concrete batching plant on the island in conjunction with Johannes Concrete on the mainland. But anywhere we could, we would precast, so or prefabricate. So we have sheet piles here on Duffy's Pier. We have the precast elements of the bull's nose, and of course we have the lock chamber. So this lock chamber, this is a 9-meter high structure. The base of it is 5 meters below low water. Traditional methods of concrete construction and constructing by divers was out of the question here. It's first of all, it's an SAC. We tried to limit the amount of in situ concrete underwater. Secondly, it's so exposed that it's quite dangerous and intensive for divers to be working at those depths, delivering the kind of tolerances we needed for the gate structure. So we elected to make this structure on the mainland a 15 by 15 meter structure, 9 meters high. It weighed about 1,000 tons. We met it up in Barone Dry Dock, a facility that's normally used to repair ships using standard construction methods. We then design and fabricated a set of temporary steel stop logs that would slot in here to close up the U and make it safe to tow it 130 kilometres from Cove out to Cape Clear Harbour to arrive on the right tide, the right weather conditions. When it landed in Cape Clear, so this is it floating in Cove Dry Dock. It was pulled out by tug on a 36-hour tow out to the island. There was no safe haven en route to the island, so picking of tide and weather conditions was critical. This was actually installed September 24th. It was actually the last tide of the year that we could have installed that chamber. In the meantime, we fabricated the storm gates in Thompson's of Carlow. The gates were taken down by nighttime rolling closures of the M9 motorway and loaded out in Waterford. We mobilised a 200-ton crane to the island and then slotted the gates into position like Lego. So today those gates are operated by 2 HPUs, one on each side of the harbour, and controlled by one touchscreen HMI and remote control pendant. And the islanders can simply, with the push of a button, close the storm gates, and over 2.5 or 3 minutes the harbour is protected from storms. And again, with the push of a button, the storm gates will open again. So it was a very successful project for us. We were delighted to be awarded the next phases of work in the following phases of work in Cape Clear, and I believe the Islanders, and Ty, who was RE on the job, can vouch. I believe the Islanders are using it with great success and quite happy with their installation out there. So look, thank you very much for coming out on a Thursday.
Okay, thank you very much. Because there's so few here, we just open to the floor for any questions. I don't think you probably need the microphone, but is there any questions? Do you want to give John or Richard? No?
Did you have any experience of the storm surge while you were doing the works? Like, when any storms come in there, did it cause you any damage to the works?
Absolutely, yeah. Yeah, absolutely. Most of the because we precast it or prefabricated most of the pier elements, they were fairly robust to storms. Where we were vulnerable was the slipway construction, where it was low tide in situ work.
Because that's exposed to the elements, really.
It is, and it's right on the outer edge. Yeah, it's right on the outer edge. It gets no protection. It really gets no protection from the island itself, and it's the waves funnel into that area.
Oh, I've seen them bouncing off the cliffs and back and forth.
Yeah, it's quite amazing. Quite amazing. It's a pretty unique area, bottleneck for waves.
Just a question there for John, just for myself. What was the time from the shortlisting to tender award? You noted during the presentation that it was a bit of a laborious process, but in real terms, how long did it take?
I can't remember, but if you take it globally, I think we were awarded the appointment in 2010, and the works were finished, Richard, 2015, wasn't it? So it's 5 years the project took. Now, there was a big gap. I think it was tendered perhaps in 2013. So there was a 2-year gap perhaps when there was a lot of surveys and assessments and studies going on to supplement the data that existed prior to that. So that took a long time. So that was the longest spell, if you like. Then of course planning and of course anyone that has ever done a foreshore lease application knows that takes a long time. So regulatory, you can certainly block out 12 to 18 months for that, and you could block out another 12 to 18 months for studies, but they'd overlap a bit. The period between inviting to tender and actually making the appointment or issuing the letter of acceptance wouldn't be that particularly long, but at the same time you had to allow time to to go through issues with people who didn't pre-qualify. They were unhappy, so you had to explain to them and try and bring them with you. And then when it came to the tender itself, equally there was perhaps people that were unhappy with the way it was done, so they had to be
And the islanders,
debriefed.
and the islanders themselves, how much of an input did they have in the final
Well,
solution?
one of the few objections to the planning application came from the islanders.
And in what respect is it?
Well, just for a particular individual, most of the islanders were very, very much in favour of this. They wanted it big time because they could see the risk to everything if this didn't happen, and if that bull's nose collapsed, they were in serious trouble. issues with partly infilling the inner basin, and the fact that by doing so that maybe there was less space in there and there was less capacity for maintaining their vessels. So we want to put in an objection on that basis. But you have to bear in mind that there was a fair amount of pre-consultation with the islanders, so we did take on board anything they wanted, and they were really incorporated into design. The person who objected really wasn't representative of the vast bulk of the islanders.
Any other questions?
Yeah, was there any deepening of either the inner basin or the outer harbour? Because I mean, that harbour regularly dried out.
Yeah, once the temporary stop logs actually remained with the job, and the department undertook then some dredging of the outer harbour.
Yeah, the outer basin has been dredged substantially. It was dried out completely, so the dredging was conducted in the dry. A hell of a lot easier than doing it in the wet. So all that outer basin, with the exception of quite close to the boom wall, which is fairly weak, and the inner side of Duffy's Pier, which is weak, there was that old outer basin has been dredged right down. So
So having done that, did you have to underpin any of the existing piers?
the Bullsnose side hasn't been. That was that's formed on an original rock outcrop anyway. Duffy's Pier is a bit more vulnerable, so there was an issue, a set of steps on Duffy's Pier. It was reinforced to halfway in 2005, but the outer section wasn't isn't piled on the inside. So it's the original stone pier, so there is a little bit of an issue with the steps there, but all in all, that whole outer basin there has been dredged right down. Now, the inner basin is still its original, dry depth as such, but big difference with being able to install the stop logs and do it in the dry.
Question at the back, sorry.
Sorry, did you have to excavate down to the storm gate? Was it below the outside harbour? And did you go down to rock, or how did you do that?
Yeah, we had about 2.5 meters of fairly silty sand that had to come out. So we had to create a bund, first of all, inside and outside of the excavation to stop the sand blowing in. And then we dug down to rock, put in our screed frame, put down a sandbag shutter, and then infilled it.
The depth, the bottom level of the gate, if you like, was selected to take account of the master plan, future development of the harbour to a much greater harbour. That harbour will have deeper bed, so the gate is designed for that deeper bed.
Right, so the harbour will be deeper than the lock gate.
To be deeper than the existing harbour is,
Okay.
much deeper than the existing.
But if the harbour then is shallower than the lock gate, there's a chance of some stuff coming out, lodging under the gate.
Yeah, I think I referred to that.
Yeah.
Yeah, exactly. That was a risk, but now that the outer basin is dredged, that risk is really very low.
Just in terms of, I know you mentioned a return period there of 1 in 100, but what's the design life on the project, and particularly with those storm gates, how was
I think
corrosion measures gated for?
Well, it's C5M, so it's 15 years into first maintenance on the main system.
Okay.
It's 50 years is the design life of the concrete structure.
And then I was just curious then about there's 2 contracts, am I right in saying?
Yeah, both were carried out. 11 Keating won both, so it's very good. It worked out well from that point of view.
And what was the decision there? I was just wondering, just before that, to actually have 2 contracts in that
Well,
kind of
only because, if you like, let's call it the main works, or the civil works, if you like, the concrete structures, was completely different work to the storm gate. So we didn't want to be excluding competent civil engineering contractors simply because they didn't have expertise and wouldn't have expertise normally in the design of a storm gate. And the converse is also the case. We wanted to allow people to tender who had expertise in structures on major steel marine structures, but who had no interest whatsoever perhaps in civil works. So it made sense to split them. But it worked out well because LK, as it happens, won both. So we had a single contractor on site, which is always preferable. Oh, absolutely.
And how did you manage, Richard, in terms of, you mentioned there 14 designers, was that a challenge for yourself in terms of trying to keep everything coordinated or interfaced?
Yeah, absolutely. Yeah, we got fairly into the design ourselves. We kind of needed to know everything that was going on. It was a lot of man hours, but it did work out well for us. I mean, there were elements there that were just so involved with so integral to the construction methodology. Like the weight of the chamber was critical. So all the time, any of the design changes, we ourselves were monitoring the effects on the weight of the chamber. We cleared the entrance to the harbour with 300 mil to spare. So right the way through the design process, we were keeping an eye on our draft. But yeah, we had great designers with us as well. You know, we were able to pick the best in their field at their field.
And was that something that only materialised after you'd won the project, or did you have that in mind when you were actually going forward competing for the project? Did you know at the outset that you would need that many designers to cover all the facets of the project?
No, I'd say at the outset we were thinking about 4 or 5. But it's never as straightforward as you envisage. You know, there was a lot of, in fairness to the Department of Marine, now they're on board, but there was a lot of regulatory requirements about floating a 1,000-ton concrete chamber in Cork Harbour and satisfying everyone that it could be done successfully. So no, yeah, far more complicated in many aspects, but some good wins on it as well.
I'm just curious as well, what time frame or window were you operating in from the start of construction to the end?
Yeah, so one of the unfortunate things about the delays during the tendering process was that we got an appointment at the end of summer. So really it's sort of dragged out the works. Now we were lucky enough to get other portions of work, other phases of work as well, but the whole construction period from placing an order to delivery was about 14 months. Yeah.
Any other questions?
One more. When you sunk your floating caisson, how did you control it? Presumably you filled it with water.
Sink is a bad word. We don't use that around here at all. It was lowered with the tide.
Okay.
So we let a little bit of water in it just to increase the draft. The structure became quite unstable if there was any more than about 400 mil of water in it. So we only let a little bit of water into it, and then it came down by tide. So actually, when we brought it in, we brought it into. It's here now. A set of jaws. So yes, that'll let me click through, which you may not. So we just kept it in a set of pre-set out jaws and held it in with wire ropes and excavators just to keep it in the right position as it lowered with the tide, and it finished up within 20 mil of where it was designed to end up.
So you didn't have to do levelling or grouting underneath it?
We didn't have to. We did do grouting underneath it. One of the we actually, what we did was we put down a single size stone between the strip footings, but we didn't actually want it to bear on too many
parts. If we had put down a slab there, inevitably there was going to be something caught between it and the slab, and you'd get a rocking. So we wanted 3 very controlled footings that it would bear on, that would have enough strength. Really, it's quite a, over the area, it's quite a light structure. Over the bearing area, 225 square meters. That won't work.
In terms of handing control back to the local islanders, and certainly all of our relevant persons have been trained in the operations gate, but do they now have the knowledge to train the next group of people to operate the gate?
Yeah, it's a good point. I suppose not. The gate is really designed to be used in a storm event and once a month for maintenance. So ideally it should be used about 20 times a month. I think in reality it's or 20 times a year. I think in reality it's used a lot more. Certainly they do build up an expertise. There is I think the department have a procedure to do a refresh with the panel. I mean, the panel they're kind of blessed in that there's a ferry operator there, so there's a core of people that are into this discipline or area, being around machinery.
Okay, yeah.
And there's a core of team leaders of about 4 or 5, and then there's other members that have to be there on watch while the gate is operating. So I think it takes a team of 3 ideally to open and close the gate. Now it can be done by one man, but just takes 3 to be watching out for people. Yeah.
Any other questions? So I think we'll call an end to it now. Just on behalf of the Civil Division, I'd just like to thank Richard and John for an excellent presentation. I suppose you can see in the preparation slides a lot of time gone into that presentation. They're great in terms of portraying the complexities of the project, things that when you look at it from on high, you think it's only a small, relatively small confined project, but there's a huge amount of elements that were going on there, significant temporary works, significant initial design, and then imaginative design and construction once the contractor was on board.